Alright guys, welcome to my latest video, and this one is the number revision, which covers literally the entire first section of the GCSE numbers syllabus. Okay, so without further ado, let's crack straight on. Here you're going to have 15 questions, so prepare yourself. Okay, so we're going to brush through. So number one, what are integers, rational numbers, and prime numbers? Well, to summarize easily, we can say that integers are actually whole numbers that can be positive, negative, or zero, i.e. numbers like 2, 0, -5, etc. Numbers that ain't fractions, decimals, but are indeed whole, like these ones. Okay, what are rational numbers? Easy. Rational numbers are numbers that can be written as a fraction. So check it out. So numbers like this, 2/5, this is rational. 0.5 is rational. Why? Because we know that's the same as half is rational. Numbers that are not rational, i.e. irrational, like this, for 0.417315 dot dot dot. Numbers that don't have a fixed pattern. Okay, and here of course we can't really guess what number is next, so hence the word irrational. It literally is not rational. We cannot make this into a fraction. Okay, and lastly, prime numbers, and these are simply numbers that can only be divided by itself and 1. Okay, so example, this includes numbers like 2, 3, well, 4 can be divided by 2, so this one is not prime. 5, yes. 6, no, it can be divided by 2 and 3, hence excluded. 7, yes, can be divided by itself and 1, and so on. Okay, now let's get on to the meat of the questions. So number 2, what do you have here? So cupcakes are sold in packs of 8, chocolate croissants are sold in packs of 6, and cheese breads are sold in packs of 12. Now my friend Sanjay wants to buy the same number of each item. So what is the smallest number of packs of cupcakes, chocolate croissants, and cheese breads that he can actually buy? So, well, here we need to spot kind of question, so we need to find the minimum literally. So here we know that cupcakes are born in packs of 8, so we literally just take multiples, okay? So let's start with 8. So what do we have? Knowing our multiples of 8, we just go up in 8 times table. So 8, 16, 24, 32, 40, and so on. Now let's look at the next one. 6. 6 goes up again in 6 times table. So 6, 12, 18, 24, 30. So here until it lines up. So here we got 12 that lines up. And the next one, cheese breads. 12, 24, 36, and so on. And the whole point of this objective is to literally see where it lines up. So choosing another nice color, well actually it's the same color, we can see that instantly that the whole sequence are all that the smallest number of packs you can buy for each one that are the same would be 24 packs each. Okay, so the smallest number of packs, so therefore that means now, but we need to see how many each pack was. So here we need 3 packs of cupcakes, I'm using a graphic tablets by the way. What else? We need 4 packs of cheese breads, and also 2 packs of, what's the last one? Oops, chocolate croissants and cheese breads. Okay, that's it. Easy question. Now let's move on to the next one. Here number 3, here we are. So here we're moving on to BODMAS. Now here they want us to work out the following. So here, let's have a look. We got 8 plus 7 times 2 minus 5. So following the rules of BODMAS, it's always brackets over division or multiplication, then adding and subtraction. In other words, we look at times in before add and subtract. So here we evaluate 7 times 2, easy, we get 14. That's it. Then we just do the calculations. 8 plus 14 is 22. Subtract against 5, we get 17. Nice. And moving on, work out the following. So now we do 12 divided by 9 plus 5. Again, following the rules of BODMAS. we do the brackets first. So if we evaluate the brackets, we know that 9 plus 15 will give us 24. And that's it. Then we do 12 divided by 24, which turns out to be a fraction of 12 over 24. Is actually, divided, since they both go into 12, we divide it by 12 and we get 1 over 2. So it's half. Easy. And lastly, 7 minus 10 divided by 2. So again, the rules of bottom mass apply. So brackets first, we're in the brackets. Now within the brackets, we have subtract and divide. So we do division because D comes before S. Now 10 divided by 2 is 5. 7 take away 2 gives us, 7 take away 5 gives us 2. And hence we have 2 cubed. 2 cubed means 2 times 2 times 2. So the power represents a number 2 to multiply at once. So 2 times 2 is 4, 4 times 2 is 8. That's it, guys. Now we move to the next one. Okay, HCF and LCM. So the highest common factor and lowest common multiple of 320, 880. How do we find this? Well, the easiest way to resolve this is using something known as prime factor tree, which I spoke about in my videos. So let's go ahead and do this one for 320 and deduce the HCF and LCM after. So all you want to really do here is just break down the prime factors, but I would try and break down easy multiples. We know this is in 10 times table, so it's 10 and 32, so we make it nice and easy for ourselves. And from here we have 2 and 5, and 32 breaks down into 2 and 16. Okay. Next one, we're going to have 2 and 8. Break down 8, we get 2 and 4, and then lastly 2 and 2. Easy. So I'll just circle these on to show that we're not using it. Okay, and we can just list how many 2's we have. So we had 1, 2, 3, 4, 5, 6. We got 2 to the power 6 times how many 5's? 1. Good. And then we do the same thing for 880. So we got 880. Breaking it down, what do we have in total? Well, we have, hold on. So we know this in 10 times tables, we break down, so we got 10 and 88. Good. Let me just change the thickness of this pen. Okay, good. 10 and 88. Next we have 2 and 5. Okay. 88 is of course 11 and 8. We know 11 is a prime number, so we stop there. 8 is not, so we go down more. This becomes 2 and 4. Break down 4, we get 2 and 2. And that's it, guys. Now we just collect all the like terms. We have 2, how many 2's we got? 1, 2, 3, 4. We circle this one. So we got 4 2's. We have a single 5, and we also have a single 11. And that's it. Now we look at the lowest common, highest common factor in both. So here let's work with this one. So highest common factor, how does it work? Well, we look at all sets of numbers here and we see what they all have in common, at least the minimum of each one. So here we can say, let's write a highest common factor down here. The highest common factor in both, they both have at least 4 2's. This one has of course more. They both have at least a 5, and only one has 11, the other doesn't, so that would be the end. So this would be your highest common factor. Now for lowest common multiple, we just see what's missing in both. Here, to make them both have the lowest common multiple after both values, this would, of course, the left hand side would require an additional 11, and this side would require an additional set of 2, so 2 2's to make them pretty much identical. Hence we could say that the lowest common for now would be 2 to the power 6 times 5 to the power 1 times 11 to the power 1. And that's it, folks. That pretty much covers the LCM and the HCF. Let's move on to the next part. Okay, so this might sound like a rhetorical question, but how do you actually simplify a fraction? Well, dead easy. you simply just divide the top and bottom by the same number until it won't go down anymore. That's it, no questions, easy. So example, just to clarify, if I had a number like, I don't know, 22 divided by, God, I think I just made a terrible choice, over 10. So we know they both go in a 2 times table, so divide them by 2. And we get what? 11 over 5. And of course it doesn't go down anymore because there is nothing left that fits the pan. So this would be it. Of course I would I would have done a better example, but I couldn't think of it. Anyway, let's move on. Okay, so here we are, number 6. Let's find 5/9 of 180 kilograms. So the way this works, we need to know what the words, this definition means. So firstly, of literally means times. So 5/9 times 180, and whole numbers are always over 1. So naturally, in the rules of timesing, we can cross simplify, diagonally to see if there's any recurrent numbers or any numbers that go into one of them. We can see straight off the bat that 9 can go into 180. Well, to make it easier, 9 goes into 18. We know it goes to twice, so it goes, we can notice I make it 2 and this one a 1, and we can see it goes 0, so 20. So it goes into it 9 times, so then we're left with 5 times 20, which is 100 kg. That's it. Now write 81 as a fraction of 63. Okay, this is pretty much the joker's question. All this really means is write 81 over 63 and then simplify. Well, that is not as easy, but thankfully we're here. We know that both numbers divide into 9, so you just gotta make sure you can smash your times table. Dividing both by 9 will give us the top one 9, and 63 over 9 gives us 7, and that's it. Moving on. So calculate the following. Okay, let's try and do this quick. So 3 over 11 times 7/12. Again, see if you can simplify, cross simplify. You can. 3 goes into 12. This goes into once, goes into 12 3 times, so 3 and 12 goes 4. And 1 and 7, 11, nope, they're prime numbers, so we multiply across. So 1 times 7 is 7. 11 times 4 is 44. Easy. Next. Now, mixed numbers. Mixed numbers, the way when we divide or multiply anything, is best we put this as improper first. So 2 1/2. How do you do this? Well, the quick trick is to do 2 times, is to multiply the bottom value and add it to the top. That's the fast way, so I guess we'll use it. So 2 times 2 is 4, plus 1 gives us 5 over 2, and then divide. 3 times 4 is 12. 12 plus 3 is 15 over 4. Now, the special rules of divisions that we must find the reciprocal or flip the second number around. So we flip this upside down, switch to the times. So hence we got 5 over 2 times, flip this number, we get 4 over 15. Again, can we cross simplify? Yes. These two go into each other. So 5 into itself once, 5 into 15 is 3 times. 2 into 4 again, 2 goes into itself once, 2 into 4 goes twice. And that's it. Multiply across. 1 times 2 is 2. 1 times 3 is 3. That's it. Now, next one. Again, let's resolve these improper fractions. So 5 times 5 is 25, plus 1, 26 over 5, minus 3 times 10 is 30, plus 3, 33 over 10. And here we have to make, when we plus or minus, we have to find a common denominator. So we notice they both go into 5, so here we should double these values so it goes over 10. So let's double these values. What do we get? So 26 times 2 is 52. 5 times 2 is 10, minus, and then copy the second part as it is. And now we just subtract the top ones. So 52 take away 33, blah blah blah, yeah, is 19. So 19 over 10 is our breadwinner. Alright, good. You guys are keeping up well, so let's keep going. Almost there. So number 9, convert 0.05 into a fraction and a percentage. Well, to convert into a fraction is dead easy. This one pretty much indicates how many zeros it should be. So firstly, 0.5, to convert a fraction, we just copy out, so it'll be 5 over because there's 2 zeros implies that the bottom should have 1 and then 2 zeros, so it should be in powers of 10. If it was 0.5, it would just be 5 over 10. If it was 0.51, two numbers, so it would be 51 over and two numbers, 2 zeros, and so on. This is a convenient way to memorize it. Of course, this fraction in over, we should simplify it. And knowing that we can divide up and down by 5, we should get 1 over 20. Lastly, converting it into percentage is dead easy. You just copy out. It's two numbers, so it's just 5%. Okay, let's move on to the next set now, number 10. Okay, so number 10, what do we have? 30 liters of fruit punch is made up of the following: 35% of orange juice, 2/5 of lemonade, a quarter of cranberry juice. Okay, that just sounds delicious. So how many liters of orange juice, lemonade, and cranberry are in the punch? Well, this is actually easy. All we have to do is pretty much find the percentages and fractions of this whole number 30. So looking at 35%, it literally indicates what is 35% of the whole number 30. That's really all we really do. I mean, in terms of non-calculator, I would firstly find 10% resolve. However, to do it properly, 35% literally means 35, and percent means per 100, by the way, in French, in multiple language. So 35 over 100 times 30. So here we can do some cross simplifying. Knock out with 0 each, so we have 35 over 10 times 3. And multiplying it horizontally, so 35 times the whole number give us 105, and divide that by 10. And here, my friends, will give us 10.5 liters. Okay, straightforward. Next one, it says 2/5 of 30. This is quite easy because 5 goes into 30 6 times. So it'll be 1 and 6. So we've got 2 times 6 is 12. This will be 12 liters. So this is of course big, large, much larger than this value. And finally, a quarter of cranberry juice. So quarter of 30. Again, so how many times 4 going to 30? Well, it goes to twice. You can half both actually, so it'll be 2 and 15. So here we got half times 15. So half of 15 literally, we should know straight off the bat, is 7.5 liters. And good. So how many liters of orange juice and cranberry juice do we have? So first we have 10.5 liters of orange juice, 12 liters of lemonade, and finally 7.5 liters of cranberry juice. Good, good. Well, next move on. So number 11. Okay, good. So recurring decimals, let's do this. So show that 0.51 recurring can be written as this. Well, a neat trick is to simply use this rule. Is to simply let x equal this decimal, and I would actually expand the recurring. Okay, we're going to see why. 51, 51, dot dot dot. And here, the whole purpose is to pretty much multiply this until we have a same pattern in the same sequence order. So for example, if I multiply this by, let's say, 100, we know that there's going to be a shift to the decimal place. So 51 will move to the left. We got 51.5151 dot dot dot. Here we know two things. Firstly, if you look at the set of numbers here, say the two numbers after the decimal, we got 51 and 51. They're in the exact same position. Because of that, we can subtract these two. So let me write here. So we're gonna have, for example, so yeah, we're gonna have x, or let's say 100x equals 51.5151, and x equals 0.5151 dot 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 dot. And that's it, easy to subtract. We can see that if we subtract, everything gets cancelled out. All of these get cancelled out. What are we left with? So we're left with 51 take away nothing is 51. 100x take away x is 99x. Dividing both sides by 99, we're left with x equals 51 over 99. And of course, this is an over. A neat trick to know is that adding both units, both digits, will give us a multiple of 3. This is how we know that we can simplify and divide it by 3. So let's do that. Dividing by 3, both up and down, will give us a lovely 17 over 33. Hence, proving this. So well done, guys. Let's move on. Here we are, rounding, estimating, and bounds. So number 12, estimating the value of this fraction. Well, estimation, usually we should always round to either 1 or 2 significant figures. The whole purpose of this is that instead of, actually trying to work this out, we can pick appropriate numbers that will satisfy this and still kind of make sense. Hence the curly equal sign. Well, let's try this out. So if I was looking at 103.61, I would kind of say that this is to one significant figure close to pretty much 100. Nice easy number. And 57.73 is more or less coming to 60. Again, clean number. So this is 3 down, 3 up. Looks quite legit. And the bottom value is 7.935. Well, I would say this is flying up to 8. Yeah, so it looks quite good. Resolving the top, 100 plus 60, we should get 160, and then 160 divided by 8, thankfully goes into each other. 8, 16, if you look at 0, into 8 goes twice, 6, 0 is 20. So we can say all of this is roughly equal to 20. And that's it. Now, if we look at the next one, number 13, what do we have? Okay, so we're doing shopping. So here we have a beige rug from IKEA which measures 15.5 meters by 8.3 meters to the nearest 0.1 meter. Okay, so here they want us to find this maximum possible area and hence find the area to an appropriate degree of accuracy, i.e. round it well. Now, let's talk about this. So, this whole purpose is to find the nearest 0.1. So this immediately implies that we should look for half the nearest unit, in other words, plus 0.05 meters or minus 0.05 meters. Okay, this would be a lower and upper bound. So, looking at this rug, if we take the lower bound of the width of this imaginary width of this rug, we should have a lower bound here of 15.45, so subtract 0.05 and subtract 0.05 here, we should get 8.25 meters. Now, an upper bound would give us something similar. Instead of subtracting, we're going to add, so this will give us 15.55 and here will give us 8.35 meters. And that's it. Now we just, of course, multiply this value, so bear with me. Multiplying, so because we want a maximum possible area, I want to multiply the bottom one. Okay, so 50.55 times 8.25, and it should give us 128.2875 meters squared. Cool. And for the sake of completion, doing the other one will give us something close. It would actually give us, hold on my pen, 125.9175 meters squared. Not bad. So it's still quite similar, not too similar, but close enough. Now, hence find this area to an appropriate degree of accuracy. Well, this one's a bit tricky because they're quite marginally off from each other. So, I mean, realistically, if we're going to round this up to say, let's say 3 single figures, the lower bound rounding up should give us 130 meters squared. Again, the 3 single figures, it'll give us 126 meters squared. Round this one to 3 single figures, will give us 128 meters squared. However, that's not close to the area. In this case, we need to round it to 2 single figures. Looking at both, because there's a 5 here and there's an 8, round this up will push us to a 3. So hence we're going to have 130 meters squared, which is above the upper bound, which is not a really good estimate. So this question is not appropriate for my answer. Usually this works if the values are fairly tight, but they're not, as the upper bound is above, this is above the upper bound. Nonetheless, the answer will surely lie between 125 and 128. But anyway, let's move on to the next question. Okay, here we are. So standard form now, the final two questions. So number 14, let's jump in. Okay, so write these numbers in standard form. So these ones, okay, not so bad. So look at 980,000. What I always do is count up the zeros, so there's 4, and I'll write the figures in front. So here we have 98 times 10 to the power of 4 numbers, 4 zeros. Well, in standard form, we always need to write in this form, a times 10 to the power n, where a takes values between 0 and 10, but not inclusive. So in other words, 1 and 0 and 10, so pretty much single unit digits. So in other words, 0, 1, 9. It takes these values. This curly brackets means less than 10, bigger than 0. Anyway, that means 98 won't satisfy, so we need to change it to 9.8. And moving the decimal across, we have to increase this power by 1, so it'll be 10 to the power 5. Easy, okay? 12.6 billion. Whew. So billion, this I'm thinking of stars, like, or how long the age of this Earth or universe is. Scientific question. Now, to write this out, billion, we need to know how many zeros are. We know that there are 6 in a million. Billion should have 9. So off the bat, we can write 12.6 times 10 to the power of 9. Again, fixing this to a single digit should be 1.26 times 10. So once we put it back, we raise the 9 by 1, which makes it 10. Easy. Now this is my favorite. Here you literally just count the zeros before the first non-zero value. Here we have 3, 6, 9, 10. So 10 zeros, 10 negative zeros. And this means we're going to have 1.02 times 10 to the power of negative. How many values are that? 10. So this doesn't mean it's minus, it just means that the decimal place the decimal shifted back to 10 times. But I just use the fact that there are 10 zeros behind the non-zero number, which kind of helps. So 10 zeros implies this. Okay, that's just little math tricks. And let's move on to the final one and see how that goes. Well, here we are. To wrap this day up, let's tackle these tough ones. So calculate the following. So 4.8 times 10 to the power 7 divided by 1.6 times 10 to the power 5. Whew, mouthful. So what I would do, since we're dividing, I would put this as a fraction, just to see it more clearly. Good, much better. Thankfully this we can cancel as we go, so treat this as two fractions. So here we got 4.8 over 1.6. Notice immediately that this value is in the 1.6 times table, which you shouldn't know, but it's actually 3 times bigger than this. So in fact we can cancel this 3 times. See, it becomes 3 over 1. Was 10 to the power 7 over 10 to the power 5. Using the law of indices, if you're dividing, you subtract the power. So here, you do subtract 7 and 5. This becomes 10 to the power 2. Hence, this final solution is therefore 3 times 10 to the power 2. Easy. Now, adding, and I forgot the bracket. Here it's literally the same thing, except now we have different powers, which cause confusion. So immediately, what I would always do these kind of questions is raise this power to make it match this power by shifting the decimal place properly. So if I was going to raise this power to a 10, we need to raise this to 2 different places, i.e. here. So popping in some zeros, and there we should get this value. So hence we should have 3.11 times 10 to the power of 10, and then here we have 2 decimals, so 0.0129 times 10 to the power of 10. Now we just sum these up. So sum these up, we got 9221.3. Hence our solution is 3.1229 to the power of times 10 to the power of 10. And that's it, guys. Hope you enjoyed this video, and I shall see you in episode 15. Damn, that was really enjoyable. Okay, catch you guys later. Ciao.